Thank you for introducing us. Only add that this work is a result of a collaboration between our center and the Hospital Clinic of Barcelona. This project is about a serious game, and I want to introduce that serious games are video games designed for a specific purpose beyond the pure entertainment. Sometimes, like in this case, they are simulations of a real-life procedures with gamification elements that make it stimulating and fun, so providing a more effective learning. The aim of this project is to create an educational tool to complement the practical training of perfusion students. This tool is a game where the player takes the role of the perfusionist and experiments on surgery that requires cardiopulmonary bypass. The potential advantage of this tool is that can complement the training, the traditional training in a participatory and active way without risk for the patient. Our hypothesis is that the gamification elements and the 3D environment can provide an extra motivation and an immersion feedback. Besides, this type of technology can be cheaper, faster to install, and can be played at home also. And finally, it can provide a personalized games with levels of different levels of difficulty, and a lot of users can be played at the same time and can be evaluated automatically. Well, we have designed a game prototype, and we have tested with perfusion students. So this talk is to present the software and discuss the results of this test. The core of this game is this mathematical model that simulates the behavior of a hair-long machine connected to a patient. You can see in the diagram in green the variables that the perfusionist can modify during the surgery, and in orange, that ones that can be seen in the different monitors and displays of the pump. We have designed this model on basis of bibliography, simplifying some behaviors, but we are currently adding more complexity to make the model as realistic as possible. Then we have added the 3D virtual environment, the interactions, and the gamification. And the result is this game that I will show you in a little video. First, we can see the medical chart of the patient, and this changes every time we play. I don't know if it's listened. Then we can start the virtual surgery, taking into account that the pump is ready and the patient is well heparinized.
On pump.
We can hear the surgeon indications, so we must interact with the pump correctly, and we can see the effect of our actions on monitors, on the different monitors of the pump. For instance, when we increase the velocity of the arterial pump, the pressures become non-pulsatile. We also modify the parameters of the gas blender of the oxygenator.
Cross clamp on. Cardioplegia on.
You can see that the time runs faster than in real life, and all the actions that player has performed will be registered to analyze and evaluate afterwards.
Stop cardio, please.
Here we can see an alert because one of the parameters has not inadequate value. I don't know, you can see what is happening here. For example, this error tells us that ACT is very low, and we can use the drugs on the table. In this case, we can administrate a dose of heparin. These errors affect our score until we fix it. You can see the punctuation in the upper right corner. Also, we can modify the temperature of the arterial line with the heterocooler exchanger, and then we can see how venous saturation increase, etc. The errors can be caused by unexpected events, like the sudden dropping of the ECT, or by the player due to a wrong value of the machine controls, like in this case. If this error persists or becomes unacceptable, the game is over.
Okay, just to say that during the game, you manipulate only with the mouse, or in a tactile, in a touch display, you can also manipulate with the finger. So it's absolutely, you can use it in any computer. So to test if our hypothesis that this game could be a good tool for training, what we did is first during the development of the game, we made validations comparing our model with real data of real interventions, and also comparing with a physical simulator, concretely the Orpheus physical simulator. And of course, this work is a collaboration, so the perfusionists of the team assessed us in the model. Then we made a pre-validation with some students of perfusion from different places around Spain. And finally, we did a longer trial with much more students. We made a trial with the students of perfusion. They were in a Master of Perfusion in the second year. There were 31 users, 23 women and 8 men. And the setup of the session was as follows. First, we explained a little bit. We made a demo, like something similar as we have seen. Then they were allowed to play freely. And then we made a questionnaire, and we had a debriefing about the technique. So the results were the following. We analyzed the number of games that the players did, and they did between 5 and 27 games in average per person, with an average of 11 games per person. They could play as many times as they wanted. So if you look at the percentage of failures than successes, we can see that there were much more failures than successes, which is normal, because you are not expected to win all the time a game, otherwise it's boring. But if we analyze the curve of learning, we can see that at the first game, nobody could win. This is normal because in this type of technology, you need to learn, first of all, to use, to manipulate, to navigate, to know how you have to touch the different buttons. But as time, with a different number of sessions, users improved very fastly, which was very important from our point of view, because we wanted to be sure that the technology was usable and easily learnable. Then, in the questionnaire that we passed to the users, we made questions about knowledge. So the kind of questions that we did, here we have an example where, like in the game, did you raise the arterial pump if the venous saturation was low? And the kind of answer that they could say was, yes, I did it, I succeeded. No, I didn't do that because it's a wrong solution. Or yes, I wanted to do that, but I couldn't because of technological reasons. So from that, we extracted three parameters. The theoretical knowledge of the students, which is represented here with the green bar, and you can see that it was very high. This was expected because we used the prototype with good students. Then we could extract their practical results, which is the red bar. You can see that for a lot of users, even though they knew the correct solution, they were not able to do it in practice. This shows us that you have to master the technology a little bit. However, the difference is not so big, which is good. And we also tested if our technology was running correctly. And this is the blue bar. And yes, the answers are good. We have to say that when they said that the behavior of the game is not correct, it is because they didn't know how to make it work correctly. Then we had other questions. First of all, we passed the SUSE questionnaire. This is a general questionnaire for any computer application that measures the usability, the degree of, the facility of the software to be understood and used by any users. The results were very good because here the score considered to be correct is 68 and we got a 72. And then we asked different questions about realism, fun, and so on. And we discussed these questions with users afterwards in the debriefing. So the conclusions were positive. The students thought that the realism of the game and the environment was very good. They all said that the technology was very promising because they agree or strongly agreed that it could be a good tool for perfusion. All of them said that we need to do a lot of enhancement, basically to improve diversification of the different sessions. And what was, for instance, for us very important, they majoritarily said that they had fun during the session, which is important for us because we believe that learning with fun is better learning. So the conclusion, we have made this small prototype and we believe that it could be useful for training perfusion. And what we want to do now is to basically to enhance the game, to diversify cases most of all, because by now our tool could be good for the first year of perfusion, but we believe that it has also a potential to be used for trained and experienced users that want to test their skills in stressing critical and non-usual situations. So for that we need to add these situations in the game. As far as we will add new situations, we will also test the learning curve of the students. And that's all for us. Thank you.